Hi, this is Aliyah, and you're watching Ophthalmology with MAS. We are starting a very small review lecture series, and the first lectures that we are doing are on lens, and the first lecture of this series is lens, its embryology, its anatomy, its physiology, and its biochemistry. Thank you. So we will start by talking about the lens and understand. We will start with how the lens is made and its embryology. So the lens is derived from the surface ectoderm, and this begins at 25 days of gestation. And what happens is that the surface ectoderm starts invaginating, forming surface epithelium, and after some time it closes up. Now these lens epithelium start forming fibers, and the first fibers that are formed are the primary lens fibers by 33 days of gestation, and they go and they start collecting in the center of the lens. This is what is known as the embryonic nucleus. Now these epithelium, they keep on proliferating and forming these fibers and proteins, which then go and start accumulating around the embryonic nucleus, and this is fetal nucleus derived from secondary lens fibers, whereas the embryonic nucleus is derived from the primary lens fibers. This keeps on happening throughout the life, but it's important to know that the fetal nucleus is completed by 8 months of gestation, while the primary lens fibers are completed by 33 days of gestation. This is important to know because if you have rubella infection in the first trimester, it will cause congenital cataracts because the fetal as well as the embryonic nucleus is not completely made, and it will also cause congenital glaucoma. However, if the rubella infection is happening after the first trimester, it would not cause congenital cataract because the fetal and embryonic nucleus are already made and would just cause congenital glaucoma. Now, this lens, the surface epithelium, keeps on proliferating and dividing throughout life, and fibers keep on collecting in the center of the lens. The lens is 6 millimeter in diameter and 4 millimeter in thickness, which continues to increase throughout life. And because this keeps on continuing throughout life, so the cataract or an opaque lens is 10 millimeters in thickness. So if we were to divide the structures of the lens, you would divide them into the capsule, the nucleus, which is made of the primary and secondary fibers, and then the cortex, which consists of the newly formed fibers. Now, the lens is one of the refractive surfaces of the eye, causing light to focus on the macula. And one of the prerequisites of that is that it has to be transparent. So it's important to understand why the lens is transparent. Now, the fibers which are being formed inside the eye consists of 80% of water soluble proteins, whereas 20% of water insoluble proteins. This balance is one of the prerequisites
to keep the lens completely transparent. If this imbalance is broken, and let's assume that the composition changes to 50% of water soluble and 50% of water insoluble proteins, the lens will start becoming cloudy. Now, as this process keeps going on, then in a brunescent cataract, the composition is 10% water soluble proteins and 90% water insoluble proteins. Now, the metabolism that is happening inside the lens is also important to know because that will also play a role in cataract formation. Normally, the metabolism that is happening is anaerobic glycolysis, which plays a role in sugar being utilized for energy. However, if there is a metabolic disorder causing increased glucose in the body, the metabolism of the lens is shunted and goes to the sorbitol pathway to make energy. The sorbitol pathway will lead to accumulation of sorbitol, which would cause a change in the osmotic gradient of the lens, which would then lead to water accumulation, which would then cause opacity of the lens, which is called a cataract.
Thank you for watching. The next lecture is going to be on pathology of cataracts or lens opacities.